All right, coffee's on and time to do quiz. So I'm going to do each problem separately by type of problem. And this is a directional derivative problem. This number 1 off your quiz 5. So number 1, quiz 5, we have f of x y is equal to x squared y plus y cubed. And the question asks, find the rate of change of f of x y from the point 1, 2 in the direction of the point 4, 6. So you're asking me how to study for the WPR. You need to know that this is a directional derivative question. Once you know that, you know which formula to apply. So they're asking for gradient in the direction of the vector. And there is no vector here, so that's like you have to understand what's being asked. And that to me is the biggest part of just what you're doing here, because the rest of it is just cranking through a machine. So let's start with the easy part first. The gradient vector is going to be the partial of f with respect to x. So we have the first one's going to give me 2xy, and the second term is going to disappear because this is really fx right here. And then the second component is going to be x squared, the derivative with respect to y. We're going to get x squared plus 3y squared. This is fy. That's the gradient. And I'm interested in at a particular point. So it's like a plugging in the point for a tangent line. 1, 2, so at 1, 2, or x equals 1, y equals 2, we have the gradient at 1, 2 is going to be 4, 13. And all I did is I plugged in x equals 1, y equals 2. And I've done this already once. My computer kind of shut down. So you can trust me this time I've actually got the numbers right, because if you're my class, you know that that's where I struggle with just plain arithmetic. Now, this is the gradient. You have fx is the rate of change in the x direction, fy is the rate of change in the y direction, but we don't want fx and fy. We want it in a particular direction, starting at the point 1, 2 in the direction of the point 4, 6. So from your previous stuff that you've done already, you need the direction vector. And the direction vector from 1, 2 to 4, 6 is going to be 4 minus 1 and 6 minus 2, which is really 3 and 4. That's a direction vector, but for the directional derivative, you need to make it a unit. You need to normalize it. So normalizing it would mean to find the magnitude, which is 3 squared plus 4 squared, which is 9 plus 16, which is 5. You've seen these in triangles already. I need to divide everything by 1/5 or multiply by 1/5. So I need to renormalize everything and put a 1/5 out in front. And if you like everything pulled into your vectors, this is really 3/5, 4/5. So how do you now finish your problem? You pull off your sheet. The directional derivative is going to be the dot product of 4, 13 dot 3/5, 4/5, which is really 12/5 plus 4 times 13 over 5. And this is where Dr. T is going to stop. I'm assuming that everybody can add fractions. Let me pull that up. You can add fractions. And whatever that number is, I really don't care. The important part of this problem when you're studying for your WPR is that it's not immediate that you know that you're supposed to find the directional derivative. It's not immediate that you know that you need to find the direction vector. So all these pieces, if you just know the formula, you won't know enough. You need to understand a little bit of what you're trying to do and what's missing here, the missing ingredients to plug into the formula. So keep that in mind, that again, that concepts are inside these rote type problems still in the way they're being asked, which is the correct way to ask things. All right, I'm going to move to number 2.